In the previous tutorial, we covered how to create a mass model, typical just, rectangle, and add mass floors to it so that we could analyze it for energy purposes. So the next thing we're going to do is now set up the energy settings that we're going to use to evaluate this particular mass model, what we're calling base building 2. And so if we go into the tab, Analyze tab, you'll see a variety of different analyze capabilities, loads, load combinations, so forth, having to do with mechanical and structural. And you can see mechanical here. But over here is energy settings. And I apologize, my icons are fairly small, but there's energy settings here. There's location, which we went to previously and set the location. We can just open that up and verify, yes, we're at 2008 Jefferson in San Antonio. So the next thing we're going to do is set the energy settings for this particular model. And you'll see right here, the first thing that comes up is mode. Okay, this is the method that Revit's going to use. You can use conceptual masses only, use building elements only, and use conceptual mass and building elements. When we're working in a conceptual stage where we've just got conceptual masses, we should use conceptual masses. Okay. If you're in a schematic stage where you may have a combination of conceptual masses and actual modeled building elements such as walls, this is what they mean, walls and floors modeled with Revit, then you may use a combination. And of course, if you've got the building modeled, you probably just want to use the building elements that are in the model. So anyway, we're going to use conceptual masses. The ground plane, we're just going to use the finished floor as the ground plane. So it's going to assume that everything below first finished floor, which would be the basement, is below grade. And basically it won't automatically put windows in it, and it'll treat it as below grade basement type of space automatically. The project phase, this is new construction, analytical space resolution. These two things here, you can look those up and read them under energy settings in the Revit knowledge base. But I'm really just use these values here. 12 inches and 18 inches are plenty high enough resolution to get you a decent model. And unless you really understand these, there's no reason to change them. The other thing that we probably need to change is what we call the perimeter zone and perimeter zone division. Okay, the perimeter zone is set to 15 feet. So let's talk about what that particularly is. And to do that, I'm going to go in here to our base building, office building, our conceptual model. And you'll notice that it's it's 90 feet by 150 feet. It's got 30 foot by 30 foot bays, though structurally that may not be the best, but it works out. It's simply. And we'll notice that, so this bay area here is 30 feet deep, and then we have a core, of course, that is 30 by 90 right here. Okay, based on that, the perimeter zone is actually 30 feet deep, not 15 feet deep. And so I'm going to change this to 30 feet. And so we've now set the zone depth to be 30 feet. And that means that that core zone will be created that we see here. Okay, because it'll go in and it'll create up to 30 feet, and then it's going to partition this off as a separate zone, so create a core zone for us, which is what we want because there would be a core zone in the model. And then perimeter zone division, we want that perimeter zones that we were talking about here, okay, to be divided up into separate zones, north, south, east, and west zones. So what we're going to do is allow Revit to do that by making sure this is checked. If we don't, that outside the perimeter zone is created as one continuous zone, and that is not normally how energy for this type of building is actually modeled. So we want to make sure that it is divided into perimeter zones. The next thing we're going to do is look at advanced options.